In another text problem, we are asked to calculate or to come up with a graph of a function whose derivative is positive between negative pi over 2 and positive pi over 2, whose derivative is equal to 0 at negative pi over 2 and pi over 2, and whose derivative is negative, less than 0, from negative pi to negative pi over 2, and also from pi over 2 to pi. There are many ways that such a function could be graphed. There are many such functions. There are many functions that satisfy these conditions. Maybe the simplest type of function would be represented by this purple graph, which appears maybe to represent some kind of a sine or cosine function. Okay, the derivative is 0 here and here, because the slope is 0. The function reaches a minimum point here and a maximum point here. The derivative is greater than 0 from here to here. That is, the function is increasing. The slope is always positive from this point to this point. And the function is negative on this side of the 0. So we start with a negative value of the derivative. We start by going down, and we move over to this point where the derivative is 0 by leveling off. And then the derivative is positive, so we increase. Now we're approaching another 0 derivative, so we've got to level off at that point. And then we've got negative derivatives, so we can go down. The red line also satisfies, or the red graph also satisfies these conditions. There's no reason that the function has to go up as much as it came down. It goes down, it comes up a little bit, and levels off. And I didn't really locate that level point quite as accurately as I'd like to, but you understand what's going on there. The level point should be right at the pi over 2. And then it goes down, but not in any consistent fashion. It goes down faster and slower and faster. It can go down any way you want it to between here and here, as long as the derivative stays negative. And of course the derivative could be, or the function could look something like this, which is very similar to this function, except it starts to level off down here. And the fluctuations are not quite as great. In another text problem, we have the problem of interpreting if f of x represents the elevation in feet of the Mississippi River, where x is the position in miles as measured back to its source, then what is the interpretation of f prime of x? Well, here's a conceivable graph where the river is gradually lowering. Rivers don't run uphill, so we think that the graph is going to always have a negative slope or a negative derivative. But what is f prime of x? Well, it's the change in f divided by the change in x. Okay, any average derivative is the change in f divided by the change in x. So that we're going to say that the change in f is a change in elevation, the change in x is a change in position. F of x is measured in feet, x in miles, so that the change in f will be the feet of elevation change, and the change in x will be the change in the position in miles. So it's feet per mile. It's the rate in feet per mile at which the elevation changes. And that makes a whole lot of sense. In another example here, P of t represents the monthly payment that you're going to have to make on some loan. We assume you're going to borrow some fixed amount of money. So P of t is your monthly payment, and t is the length of the loan. Okay? That is, you borrow $10,000 for 5 years, your payments are going to be higher than if you borrowed it for 10 years. So that your monthly payment will go down with the length of your loan. The more years you borrow that money for, the less you pay per month. Of course, you're going to approach an asymptote here, which is the interest on the money, if you think about that. The interpretation of the derivative is, well, it's the change in monthly payment per year of the loan. So it's going to be the rate at which your payment changes in dollars. I should really say monthly dollars per year of loan length. Okay? It's not the payment in dollars per year, but it's the change in the monthly payment in dollars per year over which you spread the loan.